Hi, in this session we're going to show you how you could stress test the Polygonica Boolean, hopefully to convince you of its robustness and durability. So I'm going to run some scripts, but first I'll just give you a quick idea of what those scripts do in Polygonica demo, which is just our internal demonstrator that we use to demonstrate the Polygonica API. So here I've created a simple sphere with some tessellation, reasonably fine tessellation, quite smooth, and I'm going to create a copy which is brown, and what I'm going to do is just turn the edges on that copy and then click on these little handles. I'm just going to rotate one of them a little bit. So now you can see we've got two identical spheres with identical meshes, but one has been rotated slightly, so you can see the wireframes are diverging slightly there. And then what we're going to do is do a Boolean subtraction operation of subtracting one from the other. And you can see here's the result. So just ignore these purple colouring. That's just Polygonica demo telling me that these are separate shells and that they're quite small, so they're potentially candidates for removing from the scene. But I'm not going to do that in this case. But just zooming in, you can see we've got a very nice thin set of solid faces here, or solids made of very thin solids made of faces. So the idea of this test is to create lots of nearly coplanar faces and then do Boolean subtractions between the two of them. And this is a very, as explained in the blog, it's a very difficult thing for a Boolean algorithm to deal with due to floating point precision issues, basically. Okay, so these are three different stress tests. I'll just show you this one on the right. So we've got a sphere and a cube, and this one on the right is a tooth. So it's a tooth we've extracted from an intraoral scan. It's quite good. It's quite a nice scan, but there is still noise, so it's a bit more realistic. And we've extracted it, and then we just added a base to it, just to make it a complete solid. So I'll just set these going. So as I said, on the left we've got a sphere. So this is the same as what I was doing before in Polygonica demo. So we're basically creating our sphere with a random number of faces, a random number of triangles, creating a copy of that sphere, and then rotating that copy about a random axis by a random angle, and it's a very small angle. It's well less than a degree. So you're going to get lots of almost coincident faces, but not quite. And then we do a Boolean subtraction between the two of them. The bits where it's pausing, it's when it's created a lot of facets, and that's why the Boolean takes a little bit longer on those. In this middle one, which is the same principle but with a cuboid, so each cuboid is then remeshed to a random edge length using Polygonica. A copy is made, the copy is rotated slightly about a random axis and a random small angle, and then a Boolean subtraction occurs. So these planar segments that you can see are extremely thin. So they are solids. They do have top faces and bottom faces, or front and back faces, or whatever, but they're very thin, probably less than you would be able to cope with in single precision floating point. And then on the right here is the tooth. Same principle. A copy is being made. It's being rotated and then subtracted. And you can see there's some little islands in each of these, partly I think due to a little bit of noise, there's a bit more noise, a bit more variation, a bit more surface variation on this mesh, so you get a bit more of an interesting result. But overall you can see it's running fine. It's chunking through all of those perfectly happily. There aren't any problems, there aren't any crashes, it's not freezing or anything like that. Yeah, as you can see, the Polygonica Boolean is very robust with respect to dealing with that particularly nasty case of nearly coplanar faces. Okay, thanks for listening. If you want to test out Polygonica, you're very welcome to get in touch via the contact form on the website, or if you just want a more in-depth demo, I'm happy to give you a demo via web meeting or whatever. So thanks for your time.